It can hover like a helicopter, take off from short runways, and land vertically on ships in the middle of the ocean. Sounds like science fiction, right? But it's not. This is the F-35B Lightning II, one of the most advanced and mind-blowing fighter jets ever created. With a design that breaks the rules of traditional aviation, the F-35B has redefined what modern aircraft can do on the battlefield. How can a jet packed with weapons and advanced tech take off from a small ship and land vertically like a helicopter? What kind of engineering sorcery allows it to pull off such maneuvers without sacrificing speed, stealth, or power? Let's explore the insane engineering that makes the F-35B one of the most revolutionary jets flying today. What is the F-35B? The F-35B is part of the F-35 Lightning II family, developed by Lockheed Martin. This family includes 3 variants: the F-35A, conventional takeoff and landing, the F-35C, carrier-based, and the F-35B, short takeoff and vertical landing, or STOVL. The F-35B was developed specifically for the US Marine Corps, the UK's Royal Navy, and other allied forces. What makes the F-35B special is its ability to operate in places where traditional jets cannot. It can launch from short runways, small aircraft carriers, or even remote bases with limited infrastructure. Its vertical landing capability eliminates the need for long runways, making it ideal for forward operations. But all this is only possible because of some of the most advanced engineering ever put into a military aircraft: the LiftFan system. The secret to the F-35B's vertical landing ability lies in its unique propulsion system, particularly the LiftFan. Unlike traditional jet engines that only push air backward, the F-35B's system creates vertical thrust. Behind the cockpit sits a large vertically mounted fan known as the LiftFan. It is powered by a drive shaft connected to the main engine, the Pratt & Whitney F-135. When the jet prepares for vertical takeoff or landing, a clutch engages and the LiftFan begins spinning, pulling in air from the top and pushing it down with tremendous force. At the same time, the main engine nozzle rotates downward, adding to the vertical thrust. The engineering precision here is extraordinary. The LiftFan produces 20,000 pounds of vertical thrust, while the rotating nozzle adds another 18 pounds, 0 pounds. Combined with roll control nozzles in the wings, this system allows the F-35B to hover, descend vertically, or make short takeoffs. This is engineering mastery, balancing forces perfectly in midair. Swivel Nozzle. One of the most amazing parts of the F-35B is its special rear nozzle. This part can turn downward to help the jet lift straight up or land straight down. It can swivel around 90 degrees, which means it can point the engine's power toward the ground instead of just pushing the plane forward. This nozzle is made from very strong and heat-resistant materials. That's because it has to handle the extreme heat from the engine, which gets hotter than 1,600 degrees Celsius. Even with that much heat, the nozzle still needs to move smoothly and quickly without braking. When the F-35B is landing vertically, this nozzle carefully changes its angle to keep the jet steady in the air. It uses smart computer systems and sensors that react instantly to what the pilot is doing and what's happening around the plane. It's a perfect balance of strong metal, high heat protection, and high-tech control. Pros: vectoring and stability. Flying straight up or down sounds cool, but it's actually very hard to control. If the power from the engine isn't spread evenly, the jet can start to tip, wobble, or spin out of control. That's why the F-35B uses something called thrust vectoring. This means the jet can change the direction of its engine power. It uses the main swivel nozzle at the back and also has smaller nozzles near its wings called roll post nozzles. These smaller nozzles blow out air from the engine to the sides of the jet. This helps the jet balance itself while it's floating in the air. If the jet starts to lean, the air coming out of these nozzles pushes it back into position. At the same time, the jet uses tiny sensors and a smart flight computer that checks the jet's position many times every second. It quickly adjusts the airflow to keep the jet straight and level, even if the weather is windy or the ground below is uneven. In avianimation, older jets like the Harrier could also take off and land vertically, but they were much harder to control. Pilots had to work extra hard to keep them stable. The F-35B makes things much easier. It's more balanced, smoother to fly, and safer to land, even on small ship decks or in tight places near the battlefield. This makes it a big step forward in jet design and safety, internal weapon bays, and stealth. One might assume that adding all this engineering would make the F-35B bulky or visible to enemy radar, but that's not the case. The F-35B is a stealth aircraft with radar-absorbing materials, sleek shaping, and internal weapon bays that keep it invisible. Instead of carrying missiles and bombs on the wings where they create drag and radar reflections, the F-35B stores them inside. This helps reduce its radar cross-section and maintains a low observable profile. Engineers had to be incredibly precise to fit all these weapons inside while still leaving room for the LiftFan, fuel, and avionics. The internal bays open and close smoothly to avoid radar detection during flight. The entire design is a marvel of compact and stealthy efficiency. Advanced cockpit and sensors. The F-35B doesn't just fly with incredible power, it also gives the pilot a level of awareness that no other jet offers. This jet is like a flying computer, filled with smart systems that help the pilot see, track, and react to everything happening around them. It's designed to keep the pilot fully informed without overwhelming them, using the most advanced technology ever put into a fighter jet cockpit. At the center of this system is the pilot's helmet. But this isn't an ordinary helmet. It's a high-tech tool that works like a command center. Important information like speed, altitude, targeting data, and even live thermal images appear right on the pilot's visor. This means the pilot doesn't need to look down at buttons or screens. They see everything right in front of their eyes, even through the floor of the jet. This keeps the pilot focused on the mission without distraction, especially in fast-moving combat. The jet is also fitted with the Distributed Aperture System, DAS, which uses 6 special cameras placed around the aircraft. These cameras give the pilot a full 360-degree view, even in total darkness or bad weather. When combined with advanced radar, electronic warfare tools, and secure data links, the F-35B becomes more than a fighter. It becomes a flying sensor hub. It can detect threats early, jam enemy radar, and send real-time info to other jets or ground forces. This makes the F-35B not just a powerful aircraft, but also a smart one that can control the battle space like no other. Short takeoff and vertical landing, STOVL. STOVL is the F-35B's core strength. While other aircraft need long runways or massive aircraft carriers, the F-35B can take off from small decks, remote bases, or even roads. This makes it perfect for rapid deployment and surprise attacks. Marines can operate F-35Bs from amphibious ships, moving quickly without relying on large bases. This kind of flexibility is rare in military aviation and makes the F-35B a key asset in modern combat. The engineering challenge here was to make STOVL possible without compromising speed or range. Many vertical takeoff aircraft sacrifice performance for lift, but the F-35B remains fast, agile, and capable of flying over 1,000 miles. Modular and maintainable design. Despite its complexity, the F-35B was designed for easier maintenance. The jet uses a modular design where parts can be replaced quickly. Advanced diagnostic systems also tell ground crews exactly what needs fixing, reducing downtime. This is crucial in combat zones, where time and resources are limited. By making the F-35B easier to service, engineers ensured it can keep flying even in harsh conditions. The F-35B is more than a fighter jet. It's an engineering marvel that blends stealth, speed, power, and versatility into one deadly platform. With its LiftFan, swivel nozzle, STOVL capabilities, and advanced tech, it changes how militaries approach air combat. Every piece of the F-35B was carefully designed to overcome massive engineering challenges. It's not just about flying, it's about dominating in every environment, from carrier decks to desert runways. The F-35B proves that with the right vision and technology, the impossible becomes possible. So what do you think about the insane engineering behind the F-35B? If you found this video helpful, don't forget to like, share, and subscribe for more military content.